Welcome back to another video on our functions unit. This one is on exponential functions. Let's learn all about them. All right, when we talk about exponential functions, we are talking about curved lines on a graph again, kind of like quadratic functions, but not in that U shape that we saw with the quadratics. The big difference, though, is that these exponential functions don't pass through the origin. Remember, that's how we knew if a curve was quadratic or not in this course only, is that it passed through the origin. We used the simple form of the quadratic functions. These exponential functions will not pass through the origin, so that's how you're going to tell these curves apart. Now, usually, though, we're not going to see these exponential functions on a graph. More often, we're going to see them in word problems on a test or an exam. Now, we can identify functions as being exponential if they have a percentage change of a value over the course of time. So what we're looking for is that as time passes, a value is changing by a certain percentage. Now, what I mean here is that we could have a scenario where a value is growing or shrinking over the course of time, like a population that grows by a certain percentage every year, or a car that loses its value month after month by a certain percentage, or even a science experiment where a sample of bacteria is doubling every hour. These are each an example of what I mean by a percent change over time, and they each represent exponential functions. In each case, we're going to notice there isn't a constant rate of change over time. If something's getting bigger exponentially, it gets bigger by larger and larger amounts over the course of time. And if something is shrinking according to an exponential function, then it's going to get smaller by littler and littler amounts over the course of time. As an example, let's say we have an amount of money, call it $1,000 just for fun, and it's going to grow. It's going to earn 8% interest annually. That means each year over the course of time. So this would represent an increase in the value of our money, 8% on the $1,000 the first year, and then every year 8% on the value from the year before. And of course, this percent growth is what tells us we're dealing with an exponential function. Now, the rule that we use to represent exponential functions is f of x equals a times c to the power of x. Now, remember here, f of x is just a fancy way of writing y, so we're going to write that little reminder right here. Now, let's look at that variable a in the rule. A is the amount that you're starting out with in any exponential function. So whatever the initial amount is, here it was the $1,000 worth of money. That's the a variable. So whatever the scenario is, and it's not always going to be investing money, a is just the starting amount. Now, c is a little bit trickier here. It shows how much your starting amount changes, either growing or shrinking, based on the percent change that we're given in the question. But be careful here. We always have to remember that we start out with 100% of that initial amount. Whatever we're given to start with counts as our initial 100%, and then the percent change gets applied to that. So looking at that money investment example, we had a percent change of an increase of 8% per year. To calculate our new value, though, we would have to add that 8% change to the 100% that we started out with. So we've got a change rate, or a growth rate, of 108%. Now, since we're going to be multiplying that c value, we're going to have to change that 108% to a decimal. And like any percentage, we can change it to a decimal by simply dividing it by 100. So when I divide that 108 by 100, I'm going to get a c value here of 1.08. And this 1.08 is representing our initial amount plus that 8% growth. However, and be careful here, if we were losing money, if this was a bad investment that was losing 8% per year, we'd still have that 100% sum to start out with, but we would have to subtract 8% from that. And this would represent a decay rate, or a rate of loss, of 92%. Remember, anything less than 100% is shrinking and not growing. So in this example of losing money, that c value would be 0.92, 92 divided by 100. And this makes sense also because multiplying by any number that's smaller than 1 is being reduced from its original size. So for finding the c value, all we have to remember here is figure out what the percent change is, add or subtract it from 100, and then divide by 100 to convert it to a decimal. And now for the x and y values. The x variable is up in the exponent spot, and it represents the number of time periods that pass in the question that we're being asked. So if we think of that example of investing money at 8% per year, that per year is a big hint here. It means that x is going to be the number of years that pass since the money was initially invested. Now, of course, we could be given different time frames to measure in these questions. It could be hours, days, months, anything like that. You get the idea. But X is the time periods that we're measuring with in the question. And lastly, the dependent variable, the Y variable. Well, what are we calculating here? It's always the new total of whatever our initial amount has become after X time periods have passed. So again, in that money example, if we had a value for Y, it would be representing our new total amount of that investment, what it's worth now after X time periods have passed. In this case, it was number of years that have passed since the investment. So in short, the Y value is whatever the total is today after the time periods have elapsed and we've calculated a new total. Now we have to be a little bit careful of the language in these questions. If we're given a situation where something is doubling or tripling or being cut in half over the course of time, we still have an exponential function, even though this isn't a clear percentage change over the course of time. So all we would need to do here is watch out for these key words, and if we see the words half, double, or triple, we know that the C value is going to be 0.5 if something's being cut in half. The C value is going to be 2 if something's being doubled over time, and the C value is going to be 3 if something is tripling. And just in case, if something were quadrupling, I think it's probably pretty obvious the C value would be 4. Now let's see how this all ties together in a question. If we go right back to that money example where we invested $1,000 initially and it grew at a rate of 8% each year, how much would it be worth after 5 years? In this case, all we would have to do is fill into the rule what we know from the question, and the rule was y equals a times c to the power of x. So a would be 1,000 because that was our starting amount in this question. C would be 100%, that's our starting sum, plus 8%. So 108% is the growth rate divided by 100 to change it to a decimal. So C would be 1.08. And X would just get replaced with 5 to represent the 5 years that pass in this specific question. Now watch the order of operations here. I have to do exponents before I can multiply. So what I need to do is 1.08 to the power of 5, press equals, and then multiply that by 1,000. Now watch how that's done on a couple of different calculators to make sure you understand how to do it on yours. And regardless of the method we use to do it, we end up with an answer of $1,469.33. That's the amount of money we end up with after 5 years with this investment. A nice amount of growth on our money. Now in this last example, kind of a sad one, we'll look at losing money. What happens if we start out with the same $1,000? Over the course of 5 years though, we're losing 8% per year. How much would be left after those 5 years? So here my A value is still 1,000, that's my starting amount, but my C is going to be 100% minus 8%, so a 92% rate of loss. Now don't forget we divide that percent by 100 to change it to a decimal. So here my C value is 0.92. And my X value is still 5 because I'm still looking 5 years down the road. Now you have to remember, watch out for the order of operations. Here I'm going to do 0.92 to the power of 5 and then multiply it by 1,000. Now watch how this one plays out on a couple of different calculators. Now any way you slice it, this losing investment is only worth $659.08 after 5 years of losing 8% per year. Now that's a wrap on exponential functions, folks. You should probably invest some time in another example. Here's a tougher Part C type of question for you guys to check out.